Hi everybody, this is Kanchi Sharma and I have my fellowmate Tanishka with me. So in our course, Large Language Models taught by our beloved Professor Kshitij Verma, we were assigned to make a project. So we came up with the topic Tokenizer. In this video, we'll cover our learnings and insights about the topic. I'll start by what is a tokenization. So, tokenization is a process in which we split text into small pieces called tokens, which are then further fed to machine. Tokens are a fundamental unit which represent sentences, words, characters, etc. So, why cannot we feed text directly to the machine? Why have to convert it into tokens? So, like as humans, we have a language that we understand, so as machine we convert our text into numbers which machines can understand.
So basically, tokenization consists of three ways, which includes character-based tokenization, subword-based tokenization, and word-based tokenization. And subword-based tokenization is further splits into three more different ways, which includes byte pair encoding, SentencePiece tokenization, and word-piece tokenization. So we'll learn about these tokenization later on our video.
I like to add to what you said about the subword tokenizer. So subword tokenizer is a bit better than other form of tokenizer like sentence and character because it captures more contextual meaning. So, for example, a word can have more than two meanings at the same time. So, by splitting it into subwords, we capture more semantic features of it. Also, some rare words are like represented by special tokens. So, yeah.
Okay, so let us now talk about some use cases of tokenization. So first is search engines. So when you try to write a query into search engine like Google, it employs tokenization to dissect your text. So this breakdown helps the engine to shift through billions of documents to present you with the most relevant results. And moving on to next point, that would be speech recognition systems, which includes voice activated assistants like Siri and Alexa, which rely heavily on tokenization. When you pose a question or command, your spoken words are first converted into text and then they get tokenized. And as you said about semantic meanings, so let us take an example of the word bank. So the word bank, it has two meanings. It is somewhat related to money and it is related to the bank of the river. So through tokenization, a machine can understand what is the difference and it can dissect it well, that what is the difference between them, that we as human tell a machine directly. So let us now move on to our next. So let us now understand what byte pair encoding is. So byte pair, as the name suggests, pair is taking place. So something is compressing. So basically byte pair encoding is simple form of data compression algorithm in which most common pair of consecutive bytes, or let's say characters, of data is being replaced by the byte that does not occur in the data. So let us understand this using an example. So let's say our corpus have these words: see, sun, set, uno, whose frequencies are listed here: 5, 5, 10, and 15. First, we'll convert these words into characters. So we'll split these words basically, and these are the splitted words. And then we'll combine the words which occur together most frequently, like S and E occur one time, but the frequency of word C is 5 times. So we'll write 5 in SE, and then SE is coming again, and the frequency of word set is 10 times. So 10 plus 5, 15. So this is how 15 came here. And this is our basic vocabulary, which we had before the merging of the words, and this is our updated vocabulary, which includes all the sets of words with most frequency. So that's how our serve word created in byte pair encoding. So let us now see what we have done in our project. So we took a Wikipedia page of Taylor Swift, and we basically splitted our tokens based on byte pair encoding. So that's how our tokens. So as you can see, earlier we had single characters. Now we had all the merged characters. So this is E combined with space, and this is our 256th token. Earlier we had 255 tokens because these are all our initial token. So in our code we wrote that our initial token would be 0 to 255, that is total 256, and merging will take place from 256 onwards. So that's how our project include byte pair encoding.
Let us understand the concept of BPE by seeing the pseudocode. So we have a corpus and a vocabulary. Our vocabulary has all the unique characters. So we start by iterating over our corpus by k number of times. So k here is number of merges. Different kind of LLMs have different numbers of k. We'll study this later. So here the consecutive pairs of tokens that we merge are represented by TL and TR. So we merge TL and TR and convert it into a new token. Then this T new is then added to our vocabulary. Here we can see that we replace TLR by this new token T new, and we update our corpus. So one thing we all need to understand is there, and also I got stuck in this part, that we are not replacing anything from our vocabulary. We are replacing tokens here. So yes, and we iterate it over whatever the vocabulary we have fixed, like 30k, 40k, whatever, and we merge until this number is reached.
So I would like to add BPE by saying that BPE ensures that most common words are represented in the vocabulary as a single token, while the rare words are broken down into two or more subword tokens. And this is in agreement with what a subword-based tokenization algorithm does. So let us now move on to our next thing.
So let us quickly understand with this code how the process of tokenization occurs. So here first a function encode is created. So it takes text as input, and it is encoded using the UTF-8 encoding. So it will, so the loop will iterate as soon as it finds that the length of tokens is greater than 2, and it will keep iterating it. So here we are using BPE. So the tokens are getting merged using that process where it like consecutively pairs the two frequent tokens. So here, as soon as it finds that the pair has been merged before, it merges the both the pairs into a new token, and finally it returns the token. So here we can see that the text hello world is represented by these tokens, and we can quickly see that how it is decoding. So yeah, it is decoding perfectly.
let us now understand what we were doing and now what we will do. So actually, we are gradually turning into how GPT tokenizes its things. So GPT doesn't naively merges two tokens and make the vocab. It basically kind of it has its own split patterns. On based on that, it split things like why do we need this and why we cannot rely on our previous technique. Let us see that right now. So this is the paper of GPT-2, which was published in 2019. So let us go through our input representation part. So here you can see the example where it has been written that dog dot dog exclamatory mark and dog question mark. So what our previous technique of BP merging would do, it will simply combine this word with punctuation and make it a single token. So it will combine these two things like semantic meaning of the word dog and punctuation. So it will combine that, it will combine dog and exclamatory mark, but we want these things not to get combined. So basically it is kind of clustering the things we don't want to get clustered. So that's why GPT uses split patterns to split things in more modern way. So let us now see how we have used split patterns of GPT in our code. So this is how you can see. So these three ports represent that it is a start of the sentence, and these are all representations. So simply like let us start with the hello word. So this slash p will take the word hello, and for the next word will like this is we are having the word r here. So for r we'll first have some space, and then we'll have that particular word, so that pl will represent that, and it will not take punctuation and semantic word as a combined token that we were getting in our naive process of BPE. So this is how GPT uses their split patterns to tokenize the word properly.
Thank you for that explanation. Now, I'd like to explain how the process of tokenization works in case of GPT-2 and GPT-4. So here we can see that I'm using this interesting tool called Tokenizer. So here, this is my text, and we can see that it is getting tokenized s- in the subword pattern. So here we can see that the word tokenization is getting split into two further pieces. Token, which is represented by 30,642, and the other part we can see. So here we can see that um, the uppercase word and the lowercase word, they are represented by different tokens. I'll quickly explain that. So here we can see that the uppercase word and the lowercase, they are getting represented by different tokens. Also, in GPT-2, we can see that the white spaces, these white spaces are getting inputted in different tokens. So like these, all the tokens will be inputted differently. So this is very wasteful of memory. Now, like we will see that for GPT-4, here we can see that the tokens have been decreased fairly. Now, why this has been happening? Because mainly because the white space has been reduced significantly. Here it is taking only one token for this whole white space, And also the tokenizer of GPT-4 has like better tokenizing technique for languages which are like other than English. So the language that are non-English has a very complex way of tokenizing, like they have longer sequences of tokens. And GPT-4 is encoder like CL100K base, this has a better performing in that case too. So till now we saw that what is tokenization, its encoding and decoding processes, and what is BPE. So now we are implementing sentence piece method. The code of this will be available in our GitHub link. So what is sentence piece? So sentence piece is a method which was developed by Google Research. It basically chops up words into smaller parts so that computer can analyze them better. It has many benefits over BP. So one of the benefits is lossless tokenization. When sentence piece chops these words, it makes sure that not to lose any important information. So even after the word is cut into pieces, the computer can put it back together exactly as it was before. Also, when dealing with big chunks of text, it performs blazingly fast as compared to other methods. And whenever it encounters any new word, it learns at the real time. And like this is very super handy for things like language translation. Another benefit that I'd like to state of sentence piece over BPE is that vocab size. So vocab size, as we saw in BPE, was fixed, but we have flexible vocab size in case of sentence piece. So this helps to improve the performance of sentence piece in in much better way.
So let us now recollect what we have done till now. So, firstly, we had seen about encoding process. Then we saw decoding process. Then we saw how to split patterns using regular expressions, and then we saw how things get merged in byte pair encoding. So that's how we have done in our project. And basically, in our project, at last, we have demonstrate our test cases, as tests are important. So let me go through it. So in our first test case, this is our first case test case. In our first test case, we ensure that encoding and decoding process of a different tokenizer, that are basic tokenizer and regular expression tokenizer, which is GPT-4 tokenizer. So in a basic tokenizer, we didn't use split patterns. On the other hand, in regular expression tokenizer, we use the split patterns of official GPT-4 tokenizer. So this is how we gave some test strings, and over those test strings, we test how our tokenizers are working. So this is all is being done in our first test case. In our second test case, we are comparing our GPT-4 tokenizer with our original GPT-4 tokenizer, which is present in tick token library. So this is what happening in our second test case. In our third test case, we are comparing split tokens of our regular expression tokenizer with the tick token based GPT-4 tokenizer. And in last one, we are calculating our we are basically saving and loading our tokenizer. So that's what we are doing in our project. So I think this is it for our project. So that's how we have done a project in this course. And basically we learned how to make tokenizer, specifically GPT-2 and GPT-4 tokenizer.
So yeah, thank you for watching our video till now. And I think we had a great time making this project and we learned a lot. I think we are more confident than we were before. So yeah.
This is it. Thank you so much.